what I like doing at the beginning of each class is either going over the homework or at least the concepts that we learned in the previous lesson. This way it'll sort of hammer home the points that I was trying to make. So let's go over last class. We learned a few of our first formulas in Excel, and these formulas were mainly used to clean up the data in an aesthetic way. And we talked about the upper formula, and this changes text to uppercase, and it always starts with the equal sign, the word upper, Shift 9 to open the parentheses. You can either type in the cell, C2, B4, P14, whatever, and you close it, you hit enter, copy it down if you have to. Same thing with lower, equal, lower, and then the cell. And proper, remember proper is sort of capitalizes the first letter of each word, like Gavin off, equal, proper, and then the cell number, copy it down. So that's upper, lower, and proper. We also learned the left, right, and mid formulas, and these are helpful when you're trying to grab certain characters, perhaps dates, and separate them into their own columns. The left formula, equal left, again Shift 9 to open the parentheses, then you click on the cell that you want, and then you count over the number of characters that you want to grab. If it's a year, like 2013-01-01, and you just wanted to grab the year, you obviously put 4, 2, 0, 1, 3. So equal left, Shift 9, the cell you want, comma, the number of characters you want, Shift 0 to close it, enter, copy it down. And obviously this does not have to be for a date. It can be for any type of field. The right formula is the opposite, equal right, open parentheses, the cell that you want, comma, the number of characters you want to count, over. And mid, a little bit more complicated. This is equal mid, M-I-D, open parentheses, the cell that you want, and then the starting character in that cell. So count over to the place that you want, comma, the number of characters, close it. So equal mid, open parentheses, cell, comma, character starting point, comma, number of characters. And this is great, obviously, for grabbing the day of a date, and you can separate it out that way. Now we also learned the simple day, month, and year formulas, and these are helpful if you already have the date, say 06/04/2019, and for one reason or another you wanted to break apart those dates. So the day formula, equal day, open parentheses, the cell you want, close parentheses, that grabs the day. Equal month, the cell you want, grabs the month, and of course equal year, the cell you want, grabs the year. And what I would always recommend is that even when you write the formula and you're really confident that you're getting the answer that you want, double check the formula that you just wrote just to make sure that it's correct. And the last one we learned, how to concatenate, that essentially takes the data in each field and merges it together. And concatenations are great for dates, they're great for piecing together names like first, middle, last, they're great for piecing together parts of an address. We'll work with data that has the block number in one field, the street name in the next field, the street type in the following field, and then city, state, zip code. So we're working with 5 or 6 fields, and concatenation is great at smashing them all together into one address. So it's equal concatenate, open parentheses, the first cell that you want, ampersand, quote, space, quote, ampersand, the second cell you want, and down the row. And the quote, space, quote, that can be filled in with a backslash if you're interested in smashing together dates, or you could fill it in with periods or anything you want, but whatever is between those quotes is going to be between the columns that you're merging together. So that's a quick review. Again, questions, concerns, obviously let me know, or talk about in the discussions that we might have. But what we're going to learn today, and lucky you guys, we're going to learn some math. Now, how many of y'all went to communications or journalism school to learn math, right? Scary. So good thing is Excel makes math pretty easy. So we're going to learn a number of math formulas, and to do that we're going to open up the text file that I uploaded called Lincoln_County, and that's a text file. So let's navigate there and just check it out to sort of get our wits about us. Okay, here is the Lincoln County text file, and hopefully y'all can open it up and follow along, and hopefully once you look at it you're starting to piece together what it actually is. In this case you can see that it's a comma separated file. Now we work with them a number of times, and you can see the last name comma, first name comma, middle initial, and down the row. And this is data that I requested from Lincoln County, and it's just like the other data that we already looked at. This is salary data, public information, so it's information for all public employees who work in Lincoln County and how much he or she is paid. Okay, so let's close it out and import it into an Excel sheet so we begin to look at it a little bit more closely. So I just opened up a new Excel workbook, and I named it Lincoln_County. And let's import the data. Hopefully you guys know how to do this, but if you don't, feel free to pause the video and follow along. I'm going to data. We know it's a text file. Navigate to where we stored the file. Lincoln County. Double click on it. You can see it's automatically reading it as a comma separated file, which is great. I'm not going to do any more looking at it. I'm just going to load it. And it imported 948 rows, no errors. Terrific. I'm going to close that out. And like I always do, I'm going to get rid of the banding and the filter. You don't have to, but I like to. So the banding is gone and the filter is off. Okay, let's check out the data before we do anything to it. I think I mentioned it in the previous classes, but I always like putting underscores in between the field headers, like last underscore name, first underscore name. So get used to doing that, and it's not so much important in Excel, but it will be important in some of the other programs that we use. So we're just going to get in the habit of doing that right now. So everything gets an underscore. I'm going to spread out the columns if they bleed over. Hire date, underscore. I'm going to get rid of the word pay just for the heck of it. So it's just going to be hourly rate. Spread it out, and same thing. I'm just going to make this one salary. I'm going to get rid of the words annual and salary, and pay, FTE. I'm just going to keep FTE, full-time equivalent. Okay. So we have our data. It said it imported 948 rows, so I'm going to scroll down and make sure that's accurate. 949, which is great because we all know the header takes up the first row. Dates look pretty good. Hourly rates look pretty good. Salaries, there's some blank, but I know from experience working with this type of data, salary is often blank and hourly rate is populated when you see something like that. And for personnel status, you would get a record layout to be sure, but TP usually means temporary or part-time. So temporary, part-time. FT means full-time. So a lot of temporary or part-time positions usually don't have a salary, they just have an hourly rate. Okay, so the data looks pretty good. Pretty simple, right? Nothing jumps out to me as being wrong or inaccurate. And plus I got no errors, so that's terrific. So let's do a quick review from last session. In field L1, type in the words full underscore name. Full underscore name. And in M1, type in hire year. Hire underscore year. And you can probably guess at what we're going to be doing. We're going to first concatenate the name fields, A, B, C, and D. And then we're going to split apart the year from the H field. So you remember how to concatenate? If you need to look back at some notes, feel free. But I'm going to write the formula right now, and you can see that the formula will pop up in the formula bar. So feel free to follow along if you need a reminder. Okay, mine looked like it went smoothly. And I'm going to double check. Brittany L. Abernathy. Brittany L. I'm going to scroll over just to make sure it's Abernathy. Yep, Abernathy for the last name. And remember, the first name was in the B field, so you had to start with B. Does that make sense for everyone? Again, that's concatenation, and here's my formula. It looks more complicated up here because it's not reading, it's not listing the exact cell, it's listing the header, so it looks more complicated, but our formula is correct. So now, as a review, let's break apart the hire year. Now, you might think you could use two different ones. Maybe you could use the right and grab the 2016, but when I see a date written sort of as a date, 12/10/2016, that tells me to use the day, month, year formula. If it were written as 12/10/2016, all numbers smashed together, then I'd likely use the left, right, or mid. But you can try each one of them out, double check yourself, and obviously pick the one that gives you the right information. So I'm going to try the year equal year. There we go. So the year looks like it worked. I'm going to scroll down and make sure both my formulas worked. Looks good to me. 2018. Yep. And I'm going to save. And do me a favor right here. Save it, close it, and call it Lincoln_County_original. And then copy and paste that file into a new workbook and open up that new one. So you'll have Lincoln_County_original. That's going to get sitting away in your folder. You're not going to touch it. Just in case something screws up, you can go back to that one later on. And you're just going to be working off one called Lincoln_County. Make sense? It's called Practice Safe Computing. We don't want to damage ourselves down the road. So we did a quick review, and now we're going to do some math. Okay? We're going to do a couple different formulas today. We're going to start with the easier ones, although none of them are terribly hard. We're going to find the average pay for Lincoln County employees, and we're going to find out how much Lincoln County is spending total on personnel. So we're going to do a sum and an average formula. So do me a favor and scroll all the way down. All the way down. And in, oops, I'm going to bounce over one. Make sure you go to A951, A951, where my cell is. And whenever you're doing averages or sums or percent changes, something where you're querying the entire data set, I'd like to leave a room in between the actual data and my calculation. And the reason I do that, I'll show you. Watch, I'm going to type in total pay. Shift is on. Total pay. Right? Now, eventually, if I wanted to sort the column and I do a Control A, it grabs everything in my data. I'll do it one more time, and I'm going to scroll over. See, total pay is not highlighted. But if I were to put total pay here, and I'll delete it from there, now watch, when I grab everything, I move over, Excel is also grabbing total pay. You can see how it's highlighting. So if I were to do it like that, and then if I were to sort it by hire a year or sort it by salary, it's also going to sort my total pay field. And typically you don't want to do that because that's not really part of the data. So for any calculation that you do, leave a blank cell in between your data and the calculation. So I'm going to type in total pay. Anyone know the formula in Excel to add cells together? We're going to be doing it right here in your salary column. So it would be one cell beneath your final salary data. All right. The formula is equal sum, SUM, Shift 9 to open. Then I know the data starts at the top of the row, so you can scroll up to the top. In this case it's J2. Click J2, and you can see my formula is up here, equal sum J2. I'm going to put my bar right up there. Type a colon, equal sum J2, and then scroll back down and type on the last field of your data, last cell of your data. So in this case, it's equal sum J2 colon J949. Close it out. And what this is telling Excel to do is add all the numbers between J2 and J949. Hit enter. There we go. So the total pay for employees in Lincoln County is, without commas, looks like 32 million. Highlight that field. Let's put commas between it by going up to your format box and go from general to currency. This will make it a little bit more easy to read. And I was right, 32,639,000 is what Lincoln County pays on personnel. Okay, not bad. You just added 948 columns together. Pretty easy. So that's equal the word sum, open parentheses, your starting cell point, colon, your ending cell. Close and then enter. Now say I want to find the average pay for these guys. So again, leave another blank between total pay and type in average pay. And this is going to find the average pay for all the workers who are employed by Lincoln County. And underneath your J column, you can probably guess at what this is going to be, equal average, and you can see how Excel automatically populates it when I get close. Then Shift 9, I'm just going to type in J2. I'm not going to scroll up and click on it. Then I'll put a colon, I should say. I'll click on J949, or I can type in J949, close it, hit enter. There we go. So the average pay for employees in Lincoln County is $34,500. Not bad. We did real quick sums, and actually we're going to make our life easier and say we wanted to find the total hourly rate, which is your column next door right here, hourly rate, and say we want to find the average hourly rate. Now we could type in the formulas all over again, but just switch the column headers. But you could also do this. Grab that little magic box on the bottom right hand corner of your total pay, hold on to it, and move it over. Just like that. Then release. There we go. So the total hourly rate, which really doesn't make sense, I'd never use it in a story, was $17,000. Or you could take the average salary and move it over. So on average, Lincoln County employees are paid $18.21 an hour. But again, I didn't have to write the formula again. I just had to grab that little magic box and drag it over. And that's total pay and average pay. Let's filter the data and look at just the folks who work with the sheriffs and find out their salary information. So I'm going to scroll all the way up, and I'm going to turn my filter on, and I'm looking in the location description field, the F column, for the Sheriff's Department. So I'm going to click on the header. I'm already at home. Filter, filter on, the drop down box, click off everything, and just select Sheriff's Department. There we go. Okay. Now you remember, once we filter the data, we don't want to really work with it in this Excel spreadsheet. We want to copy it over into another sheet. So let's do that. Click on a headline or a header, select all, copy, and in the second sheet, paste it. There we go. And double check your work just to make sure that the only location description or the department name that you have is Sheriff's Department. Now while I'm at it here, I'm going to name this sheet Sheriff, and I'm going to name the original sheet, I'm going to turn my filter off to start with, and I'm going to name that All Data. So I'm going to turn my filter off, and bingo, all my other data pops up. I'm going to name the original sheet All Data. So I have All Data and then Sheriff. And say our story wanted to look at how much this county, Lincoln County, is paying folks who work with the sheriff. So this is what I would do. One, I might query all the data just to sort of give me a maybe a starting point. Okay, folks make on average $34,000–$35,000 a year. If I really want to find out if the Sheriff's Department folks are making a lot or a little, maybe that's something, that $34,000 is something I can compare it to. So we have just sheriff's employees, and there looks to be how many? 142 of them. Okay. Do the same thing. Find out the average pay and the total pay for folks who work with the Sheriff's Department. So I'm going to start with total underscore pay, and again I'm going to leave a blank cell in between my data and my calculation, and I'm going to type in equal sum J2, and I'm just going to click on J143. The whole field lights up. Enter. So total pay for folks who work at the Sheriff's Department is $6.5 million. So that's essentially their payroll. What about the average pay? Average pay equal, remember the formula? Average J2. So equal formula, equal average, I apologize, shift 9, starting cell, which we know is J2, colon, J143. So add all those numbers up, close it with a shift 0. You can see my formula right up here, or right down here, and enter. That's interesting. The average pay for someone at the Sheriff's Department is $46,000. And let's remind ourselves that the average pay for county employees was $34,000. I don't know, maybe that's the first query for a story. Maybe. It takes a lot more reporting, but that could be a starting point. Now let's say we wanted to find out if the folks who were hired by the Sheriff's Department years ago, say in 2003, or heck, 1995, how much more they paid compared to the folks who were hired more recently, like in 2017 right here. So let me show you how to do that. It's a simple formula, pretty much the same thing that we just used, but there's a little caveat, and in this case, how would we group all the higher years together? Any ideas? What about just sorting them? It's not perfect, but if we sort by higher year, so select all, and notice that when I scroll down, my total pay and average pay are not selected, which is great. And then let's sort by higher year. Sort and filter, sort, custom sort, higher year, smallest to largest is fine. Okay, who do we have here? We have 1989, he's been there forever, he's the sheriff. 1990, 92, 95. So we have maybe 11 people or so who are hired in the 90s. Then we have a bunch who are hired between 2000 and 2010, and a bunch after 2010. I think I said in one of the earlier classes that a lot of times all you want to do is just ask the data questions. I'll probably never use this in a story, the formulas that we're going to write, but you never know. So I'd like to pepper it with different types of formulas and queries, ask it more questions than I think I'll ever need to, because you never really know what type of answers you're going to get. So again, this is probably something I wouldn't use in a story, but we're going to try it out anyway. In 01, again, in this case I'm skipping N, and I'm starting in O because this is going to be a sort of a calculation, and I don't want to sort it if I have to sort my data again. So in 01, type in higher decade. It's not necessarily going to be a decade because we're going to include all the 90s or all the 19s together. So say I wanted to find the average pay for all people hired in 1990, and then the average pay for all people hired in 2000, and then all people hired from 2010 to present. How would I do that? So underneath higher decade, I'm going to type in, I guess 1990s would be alright, given that one person was hired in 1989. So here I'm going to type equal average shift 9, and I just want to find the average pay for the folks hired in the 19s. J2, colon, and it looks like J12. There we go. Close it. 62,000. That sort of makes sense because look how much the sheriff is paid. He's paid 126,000 just by himself. Okay. And then I'm going to type in, just for practice, 2000s, and I do the same thing. Equal average. Start with my first 2000, which I think is J13. It should be, because I left off at J12. Colon. Scroll down to find the last 2009, because we're going to grab 2010 by themselves. And it looks like J53. Oh, you notice I didn't type in the colon, so I screwed up, and this might be a good learning experience. I didn't type in the colon after J13, and when I clicked on J53, it replaced my J13 up here. So that's a good little learning experience. So I'm going to retype J13, make sure I type the colon. There I go. Now I could probably click on J53, and it pops up. My data is highlighted, which is great. Close it, hit enter. We'll see if it worked. Yep, 51,000. That's probably sort of what you'd expect. And if I had to guess, I'd guess the people hired after 2010 were paid the least just because they're the most inexperienced. So 2010s. And here I go. It's going to be equal J54, because I know I left off with that, colon. I'm going to scroll all the way down because I'm going to grab the rest of the decade, and it is J143. Everything highlights, and if I wanted to double check my highlight, I'm just going to scroll up, see where it left off. Yep, looks good to me. Close it out, enter. Ooh, another mess up on my part, and again, this is good too. See what I did wrong here? And the Excel is giving me an error. I forgot to put the word average, so equal average. Excel will give you that hashtag value when it's saying, hey, wait, what are you talking about? I don't know what to do. So I retype the word average, enter. Let's do one more set of calculations with this data, not necessarily the sheriff data. So go back to your all data tab or your original worksheet, right? And let's filter the folks who work with the different type of tax departments. And again, this is under the location description field. So scroll up and filter that. Okay, here we go. Click on that headline. Home's already selected. Filter. Filter. I'm going to turn them all off to start with. Scroll down. And there's a couple different tax departments. There's tax listings, tax mapping, and tax reval. Okay. I have them all right here. And I'm going to copy them, select all, and then copy. Copy, and I'm going to paste these into a new worksheet. Control V, they all pasted over. Perfect, along with the header. Remember, if you didn't have your cursor on a headline when you went to select all and copy, the headline does not get pasted over, so you might want to do that. And I'm going to call this sheet, instead of sheet 3, I'm going to call it tax. Okay. Let's say I wanted to find the average pay for everyone working in the tax department, as well as the average pay for the 3 subgroups, mapping, reval, and listing. Why don't you guys try doing that on your own? And I'm going to label them average, total, average listing average mapping, the final one, average reval. And again, this is just practice. The more you do these formulas, the easier they become, and they become second nature. So equal total, here we go, equal average, J2, we have 31, close it out. So this averages them all. Now how would I average just the different subgroups? Any ideas? Well, it would be just like the different years. So let's sort them first, and sort by location description, custom sort, location description, A to Z is fine. Good, now you can see I have listings all first, then a couple mappings, then a couple reval. So if I got a job offer at the tax department, maybe I'd look at data like this to say what department pays the most so I could squeeze myself into that subgroup. So let's do the average mapping first. I'm sorry, let's do the average listing. Equal average, scroll all the way up. It's going to be an F2, but I don't want F2. I want the salary, so it's going to be J2. And I go down to, looks like 14 is the F14 is the last listing. Go down to J14, close it, enter. Listings get paid an average of $41,500. Mapping is next, so put your cursor in the mapping cell, equal average first mapping looks like J15, makes sense. The last one was J14 to J20, enter. 44,000, even more. Okay. The last one, revaluation, equal average, and let's see how the revals go. J21, colon, J31, that selects all, that looks good, enter, 38,000. So mapping are paid the most. So you could have a sentence in your story that on average, employees who work in the mapping section of the Lincoln County Tax Department are paid the most. They're paid $44,500 compared to $41,500 for the listing subgroup and $38,700 for the reval subgroup. Okay, not bad. Now let's try one more formula. And you notice how we've been using the colons in between our first cell and our last cell. And what that colon does is say, grab everything in between. You know, grab the first cell down to the last cell. But a lot of times when you average, you don't want the entire list of cells. You only want a couple of them. So how do we get around that? Let's try this. Let's try sorting the data by salary. So select all, sort your tax data by the highest paid. And salary, and go largest to smallest. So sort salary, largest to smallest. Okay. Here it is. 77,000 in the listing department. He's the highest paid. 62,000 in the reval, and 61,000 is the highest paid in the mapping. Say for one reason or another, I wanted to find out the average salary for the two top employees in the listing department. So we have Susan Sane, who makes $77,900, and we have Patty Setzer, who makes $53,700. Say for some reason, I don't know why I do it, but my editor asked, what's the average pay for the two top folks in the tax department listing subgroup? How would you do that? Because you can't grab all these, because then I'm taking into consideration all the mapping to reval folks. So scroll down and make a new field, call it average top listings. I'm going to spread that out because it's bleeding over into the next column. Okay. Here's how you average data that are sort of separated by other cells. So it's equal average, open your parentheses, click on your first one, 77, then click comma. Now type in your second one, 53. So equal average J2, comma J7, then close it with a shift 0. You see how just those two are highlighted? So Excel is only going to average those two cells. Enter. There you go. The two top employees make $65,800. So maybe that's part of your story where the two top employees average $65,000, and maybe if you were to query the data more, you'd find out that everyone below makes an average of $30,000. Now I'm making this up, but maybe that's something you'd use the information for. And summing it can be the same thing. Say you wanted to sum the two top employees. So create one more field and call it underneath average top listings, call it sum top listings. And now just sum those two. So equal sum. I'm going to scroll up to make sure I got the right cells that I want. J2, comma, and I think it was J7. Yep, J7. Close it, enter. There we go. Excel summed just those two cells. Okay? So we can cell, colon, cell to average or sum all those cells in between, or cell, comma, cell to just add certain cells together. And you can have a list 100 cells long. Cell B2, comma, B3, comma, B16, comma, B21, whatever it might be. You can just pick out the cells that you want and to either sum or average. How does that all make sense? So that's Excel. A couple easy formulas with summing and averaging. We're going to open up some new data, and we're going to run some a little bit more complicated math queries. Let's say that your county, in my case Mecklenburg, had a recent spate of gun deaths and injuries, right? And I'm a reporter, and I want to find out how that compares to other counties in the state. So I request from North Carolina officials a list of all firearm deaths and injuries by county, say since 2010. And they send me this file. If you haven't downloaded it already, please do. It's called firearm_deaths_injuries. And if you look closely, you can see that it's a CSV file. So it's a text file that looks like an Excel file. And you can see it has a little, I think it's an A here as opposed to the 3 lines on Excel. And also if you do a right click, properties, you can see Microsoft Excel, comma, separated value file. So we can treat it just like an Excel file. The only thing different from this one is we can't create tabs on it you know, like 1 worksheet, 2 worksheet, 3 worksheets, unless we do a file save as Microsoft Excel. So we're interested to compare how firearm deaths and injuries on our county, Mecklenburg, compare to other counties. So let's open it up and see what the data look like. Okay, I'm going to get rid of this warning up there. It doesn't mean anything. And I'm going to spread out the columns. You highlight all, and you double click. Okay, and if you haven't already, let's practice safe computing. Close this file out, copy, save the one as firearm deaths or injuries original, then open up the other one. Always make sure you have that backup just in case, right? So this is the data we get. And you can see the fields are county, year 2010, 11, 2012, 13, 14, 15, 16, and 17. And these are all firearm-related deaths and injuries by county for each year. And if we got all the counties, it should be 101 total rows because there are 100 total counties in North Carolina. Right? And we're interested in Mecklenburg, at least I would be, being a reporter at the Observer. So we want to see how Mecklenburg compares to other counties in North Carolina, particularly to other urban counties, like Wake, for instance. But first, let's get a sense of the state as a whole, you know, and how all the counties compare to each other. So why don't we total up the total number of gun deaths and injuries for each county since 2010. So from 10 to 17, total number for Wake, total number for Iredell, total number for Cumberland, etc. So in J1, just type in total, right? And if you wanted to sum each of those totals for each of those counties, do you know what query you'd write? What about this formula? Equal sum, just like we did last time. Shift 9 to open it up. Click on the first one. In this case, it's B2 colon, because we're going to copy them all. Then it's I2. You can see it highlights for all Wake County from 2010 to 17. Let's close it with a Shift 0. Enter. So this is telling me that from 2010 to 2017, Wake County had a total of 486 firearm deaths and injuries. Now mine didn't automatically copy down, yours may have, but I'm going to click that magic box, and there we go. It should copy them all down. Look at that. That's the same type of sum formula that we wrote with the Lincoln County records. This one is just going horizontal as opposed to vertical. Let's do the same thing for average. So I'm going to scroll back up, and I'm going to type in average. Now can you all write the average query? Equal average B2 colon I2. It's selecting them all, which is great. Let's close it out, hit enter, and shift down. Copy it down. There we go. So now we got the total for each county for all years, and we got the average per year for each county. Now how about we just do a quick sort to see how Mecklenburg fares. So select all and sort it by total firearm deaths and injuries. So sort on the J column, the total descending. Custom sort, total largest to smallest. So this is going to put the county with the most deaths and injuries up top, and there's Mecklenburg up top. And that's probably not too surprising considering only Mecklenburg and Wake County have about 1 million people. But what might be surprising is Mecklenburg has 817 compared to Wake, which is sort of about the same size, has 486. And what I like to do is I like to write sentences for each of my queries, and I like to do it pretty quickly. That way, if I have to jump off to another story or if I get tied up, I'll have some sentences that put my formulas into words right away. So what you could say for something like this is, from 2010 through 2017, Mecklenburg County had more than 800 gun deaths and injuries, about 60% more than Wake County, state data show. Right? And you can go on to say, according to the data, Mecklenburg is the only county to average more than 100 firearm deaths and injuries a year. And you can see that by right here. No other county averaged more than 100. So I would log that into a Word document or a Google Doc under Notes if I were to be starting to write a story on this. How about we find the percent change for 2010 through 2017 for each county. Now that's a new formula that we're going to learn. It's called percent change. And essentially what that is going to tell us is how much did this number, 2010 number, change when it jumped up to that number. Or Wake County's 52 change when it jumped up to 64. So in L, type in percent change. Percent underscore change. I'm going to widen that one. Now this will be a new formula for you. And you can remember this formula because most journalists hate math. So you can think of the formula as NOO. And here it is. It's equal parentheses new value N minus the old value O, close parentheses, divided by O, the old value. We hate math. We always say no to math, N-O-O. So let's try it out. Hopefully that makes sense. Equal the new value, if we're trying to find a percent change from 2010 through 2017, the new value would be 2017 minus the old value, which would be 2010, close it, divided by the old value. So equal L2 minus B2 divided by B2. New minus old divided by old. Percent change. And we'll copy that down and I'll explain to you what it says. So what I would write for this in my notes is, and if I'm concentrating on Mecklenburg, is from 2010 through 2017, firearm deaths and injuries increased 23% in Mecklenburg County. There you go. And if I had to, since I was concentrating on Mecklenburg, I'd certainly write that. But for the heck of it, let's do a custom sort. And we're going to sort it on percent change, largest to smallest. And you can see that these are all sort of an error. And the reason they're an error is because it's dividing off of a 0 right here. So Excel's saying, okay, you want me to divide off a 0? That doesn't make sense to me. I'm going to give you an error. And you can see Alexander County actually increased 400%. Because what I would do is multiply that 4 by 100 to get the actual percent. But they only had 1 to begin with. So that's not fair. If you find out New Hanover had 14 to begin with and jumped up to 36, I might include that in a sentence that said, although Mecklenburg County increased 23% from 2010 through 2017, New Hanover County increased 157%. Does that make sense? So that's percent change. We're measuring the difference from one value to the next over time. Now let's actually do the actual difference. We're not doing a change, we're doing the difference between two values. So in M, type in difference. Okay, and we're going to stick with 2010 through 2017, even though we could do the same formulas that we did for 17 to 16, or 17 to 14, or 16 to 13, it doesn't matter. But we're going to see how many it changed, not a percent, but just from raw numbers 2010 through 2016. So let's do that. Equal, and in this case, I'm going to do sum 2010, or I'm sorry, 2017, that's going to be my first number, minus my second number. Just a simple subtraction with the word sum in front. Close it, enter. Let's double check our answers just to make sure we did it right. So Dare County had 8, and that makes sense. Has 8 in 2017, 0 in 2010. So the difference, the raw number difference, is 8. What about Warren County? 2 in 2017, 1 in 2010. So that gives you another possible sentence to write. And if we're going to concentrate on Mecklenburg, let me do a search and find for Mecklenburg. So you could write another sentence that says Mecklenburg's 123 firearm-related deaths and injuries in 2017 was 23 more than it had in 2010. Something like that. Does that make sense? So that's sum, average, percent change, and what I'd like to call difference. Now we can also do the same for the bottom half. Now say that we wanted to find this information by year, because we were measuring by county, the total for Graham County, you know, and the average for Graham County, and the percent change for Graham, and the difference for Graham. So we were doing it by county. Now what if we wanted to do it by year? We'd just do the same thing, but at the bottom of our spreadsheet, sort of like we did for the Lincoln County salaries. So in A103, again, I'm going to give myself a one cell break. I'm going to leave 102 empty. And I'm going to find out the total number of firearm deaths by year for all years from 2010 through 2017. So I'm going to click total in A103, and I'm going to do the same sum that we did before. Equal sum, I know it starts at B2, B2 colon B102, you can just click on it, close it, enter. So this says that in 2010, there are 1,116 firearm-related deaths and injuries in North Carolina. Now, how does that compare to 2017 and all the dates in between? Well, rather than writing the formula again, we can click on the magic box, the bottom right-hand corner, just drag it over to the final year, which I think was I, and there we go. And actually, we can drag it over one more to get the total in. Let's do that. There we go. So what this tells me is that from 2010 all the way through 2017, North Carolina had more than 9,750 firearm-related deaths and injuries. And I got that data right there. I typed that up into my Word document or my Google Doc, store it away, because this is part of my reporting. You know, I'm not speaking to spokespeople. I'm asking the data questions. Now let's do the same thing and let's find the average. So the average for each year. Can you all take a second and do that? And I'll do it too. I'm going to label a field first, or the column, equal So there we go. You do one, you grab the magic box at the bottom right, drag it over, and you can see the average number of deaths for all counties in 2010 was 100, or was 11, and it jumps up to 13.72 in 2017. All right. Now we're going to keep moving down, and we're going to do a percent change. And we're just going to do a percent change from 2010 through 2017 for the total. So this would help me out to see if I was doing a story on Mecklenburg and Mecklenburg's percent change jumped 23%. Well, how did the state as a whole, how much did that increase or decrease in those years? So I'm going to do percent change, and I'm going to label it 2010, 2017, just so I don't get it confused with another query that I might run. In this case, it's equal. Now you remember the percent change formula? We hate math, so it's no, new minus old divided by old equals new value minus the old value divided by the old value. I have to divide it, I apologize, divided by the old value. One second, let me write that over again. Equal new minus old divided by old. There we go. There we go. So it looks like the percent change for Mecklenburg, which is 23%, is basically on par with the percent change for the state. That's interesting. And you can see that I just typed in, it was giving me a fit, so I just typed in 1,116, but essentially it's new minus old divided by old, which is 1,116. So you could say that Mecklenburg County's 23% increase is on par with the state's increase during that time. Something else that I would make note of. We're going to keep building on percent change, and rather than doing a single percent change, 2010 through 2017, let's do a percent change by year. In other words, how much did it change from 2010 to 11, 11 to 12, 12 to 13, 13 to 14. Again, this is all just asking the data questions. Some of it I may use, some of it maybe not, but you never know what the answers that you're going to get until you write the formulas. So I'm going to call this percent change by year. So type in percent change by year in A109. Any idea what formula this would be? Very similar to the previous one. Equal new minus old divided by old. And I want to do it by year. So I'm starting with 2010 to 2011. New minus old, close it, divided by old. Enter. Take it and drag it across, and I don't have to drag it all the way over because it's one behind. So what this is saying is that the number of firearm deaths and injuries for all of North Carolina from 2010 to 2011 increased 2.5%. From 2011 to 2012, it increased, or actually decreased almost 1%, 0.7%. And from 12 to 13, it increased 3.7%. So again, this is all those percent changes by year for the year previous. 10 to 11, 11 to 12, all the way up to 16 to 17, the final one. And you can double click on your query or on your formula just to make sure. New minus old divided by old. All right. And the final one we'll do, for percent change anyway, what if my editor was curious if, since 2010 is a round number, what is the percent change for each year since 2010? In other words, how does 2010 to 2011 compare? What about 2010 to 2012? Or 2010 to 2013, 14, 2010 to 2015, 16, and 17. So we want to keep one thing common or static. We want to keep the 2010 static. So in this field, type in percent change since 2010. Percent change since 2010. Right? And what you want to do here is start with your new. So equal open paren, new, which is 2011's total, right? And since we want to keep the 2010 static, here's how to keep it static. It's called locking a cell in Excel. So C103 minus $, B, $103. Then close it. And you can see it lights up. And what those $signs say is no matter where my formula goes, as far as I drag it to the left or if I drag it up or down or wherever, always refer to the second one at B103. My first one, my new can change, but always keep this one locked. And speaking of keeping it locked, we also have to divide it. So we want to divide it by the same thing. $, B, $103. Again, it's lit up down here, so it should be good. Let's see. Enter. And this is good so far because our first two should be the same answer. But as I drag it, it should not equal what I have up here. Let's drag it across. There we go. See how that changes? And let me see if I can explain it to you a little bit. What this one is saying, when I double click on it, is this is saying, what is the percent change for the total number of deaths and injuries from 2017 to 2010? And if I were to click on this one, let me escape that. You can see this is 2016, but 2010 stays locked. And that's how you lock a cell. You do it with a $sign before the letter, then a $sign before the number. The last formula that we'll go over is a straight percent, not a percent change. So for instance, I'm concentrating on Mecklenburg, and I know that Mecklenburg had what? 817 total firearm deaths and injuries from 2010 to 17. Let's see if I can scroll up and find it. believe it was 817. Here it is, yep. So what if I was curious about how does that 817 compare to the entire state? In other words, what percent of deaths and injuries by firearms for all of North Carolina does Mecklenburg, quote unquote, own? So let's do a favor and let's get Mecklenburg on top. So let's sort it by total firearm deaths and injuries. Select all, custom sort, not by percent change, but by total. And we want the largest number on top to get Mecklenburg up there. Okay, there's our 817. Now I'm going to type percent of Mech. I'm doing it away because this is just a standalone query just for Mecklenburg. And the idea here is to see how many firearm deaths and injuries are in Mecklenburg and what percent of the pie of the total North Carolina deaths and injuries come from this county. So that query, or that formula, is equal shift 9 Mecklenburg, right, divided by the total. And the total would be, we did that lower, 9,757. Let's close it. I'll scroll back it up to show y'all. So equal, open parentheses, J2 divided by J103, enter. So a sentence here could be, Mecklenburg's 817 firearm deaths and injuries since 2010 total about 8% of all the deaths and injuries in North Carolina. Maybe that's interesting. Maybe that's on par with our population and the percent of population that lives in Mecklenburg compared to North Carolina. But it's another query that I would run just to have it in my toolbox, so to speak. I could have written a lot more, but here are my takeaways from the quick formulas that we wrote. Right? From 2010 through 2017, Mecklenburg County had more than 800 gun deaths and injuries, about 60% more than Wake County state data show. And you see how I'm attributing our information to state data. Then according to the data, Mecklenburg is the only county to average more than 100 firearm deaths and injuries a year. From 2010 through 17, more than 9,700 North Carolinians have been killed or injured by guns. Gun deaths and injuries increased statewide more than 20% from 2010 through 2017, an observer analysis found. And finally, Mecklenburg totaled about 8% of all gun deaths and injuries during that time. See, I would write something like this, I would attribute it, and I would store it in a Word document to kind of put my formulas into English. So when I either talk to my editor or review my notes later on, I have it right here in front of me, and I can build on this. This will help me with my reporting. Your homework. I posted a file called census_poverty, and we'll take a look at it now. Here it is. Looks like this, census_poverty. And it's sort of like the firearm data, how it's by year, 2014, 15, 16, and 17. And it's by county, although not all counties are listed. And this is census data, which lists the number of people below poverty for each of those years. Okay, so treat it sort of like the firearm data. You can look back at the firearm data if you have any questions. But here's your homework. I want you to create columns in the data and calculate the following. The total number of people below poverty for each county from 14 to 17. The average number of people below poverty for each county from 14 to 17. The percent change of the number of people below poverty for each county. Now notice this is from 2016 to 2017. And then you would also calculate the total number of people below poverty for each year from 14 to 17, the average number of people below poverty for each year from 14 to 17, the percent change of the people below poverty from 16 to 17, note 16 to 17, and the percent change of the number of all people below poverty from 2014 to all other years. Hint, this is where you'll have to lock the cells, sort of like we locked B103. Now I'm going to help you get started. So I'm back at the data again, and if you haven't downloaded it, you can do it now, but I'm going to start filling out the headers for you. So you want total for one set of questions. You want an average here, all right? And you want a percent change here. I'm going to widen that column, just like that. So that'll get rid of some of the by county questions. Now you also want a total number of people below poverty for each year. So you want a total down here. You want an average for each year. So you want an average. You want a percent change, not for each year, but for 2016 to 2017. Percent change of the total number of people. So percent change 2016, 2017, and you want percent change since 2014. And again, this is locking 2014, but getting it for all the years. Hopefully that helps. Reach out to me if you have any questions, concerns, or thoughts, and I will see you next time, folks. Bye.